Hello, this is Minhaj Rahman from School of Mathematical and Computational Sciences from University of Prince Edward Island. First of all, I would like to thanks for the organizing committee of the Computing 2021 workshop to give the opportunity to present my research talk. Today, I am going to talk about the implementation of Dewblock clients on mobile platform. Before I start, I would like to give an overview of my talk. First, I will introduce the motivation for the development of Dewblock, followed by a brief introduction to its architecture. Thereafter, I will introduce the Dewblock app, the mobile adaptation, the implementation of this proof of concept mobile Dewblock client will then be discussed. At the end, there will be concluding remarks and the future development will be described. Since its description, blockchain has been a popular technology. However, despite its revolution of security technology, blockchain cannot always be used in its traditional structure. In the blockchain architecture, each block needs to keep the data from the whole blockchain. As the addition of each new block increases the length of the blockchain, the storage requirements for blockchain participants are ever increasing and can become quite large. As a result of this ever-increasing and often already large storage requirement, low-storage end-user devices such as mobile phones, tablets, personal computers, and so forth are often unable to participate directly in blockchain. At present, the Bitcoin blockchain is over 300 gigabyte. This places it out of reach for mobile devices, as few people have 300 gigabyte to spare on their phones, most of which do not have that much total storage to begin with. Up until now, the size limitation has always been accounted for by the idea of lightweight client, which has problem of its own. But before talking about the problem, let's discuss what exactly is a lightweight client. The idea of lightweight client is that they do not store much if any of the blockchain, reducing the storage requirements and allowing them to be deployed on smaller devices. However, it depends on the another specific server called a full client, which contains the whole blockchain. Any action requiring interaction with the blockchain must be done by the full client to which the lightweight client is bound. Thus, a cryptocurrency wallet app must depend on another server to actually make transactions. This reliance on another server is what causes the issues with the lightweight client solution. The point of blockchain client is to be decentralized. However, lightweight client is forced to trust a central server or wallet provider for all major activity. This has already been demonstrated to be a problem with cryptocurrencies. Wallet providers may not be trustworthy. In 2011, the Mt. Gox exchange, a leading wallet provider, had 25,000 bitcoins stolen from it. A few days later, user data was leaked, resulting in theft. Then, a couple days later, they were hacked. In 2014, they admitted to losing 7% of all bitcoins, probably to theft, which was worth 473 million USD at the time. Mt. Gox was then replaced by Bitfinex. In 2015, 1,500 bitcoins were stolen from Bitfinex in a hack. In 2016, almost 120,000 more bitcoins were stolen in a hack. After allegedly manipulating prices in 2017, in 2019 they were sued in New York over how they cover up an 850 million USD loss. Thus, the lightweight client model is not a good model because you lose the security of the blockchain system in order to solve the data size limitation problem. A better solution was needed and expected. Dewblock was designed to be that solution. Dewblock gets rid of the lightweight client or wallet. It replaces it with a client that does not store the entire blockchain, somewhat like the lightweight client. However, it is able to participate in the blockchain and maintain the feature of a full node. The design is based on Dew computing principle, specifically Cloud Dew architecture. Let's see how it works. In Dewblock, there are two types of server: Dew server, which replaces the lightweight client, and Cloud server, which functions a lot like typical blockchain nodes. Cloud server contain the complete blockchain, but Dew server do not, allowing them to function on smaller devices. Dew server participate in the same peer-to-peer network, unlike lightweight clients. Additional types of communication, some of which occur only between certain types of nodes, facilitate this new network. That effectively makes a two-tier network, where some communication only happen within or between certain subnetworks. In the Dewblock model, as opposed to the traditional blockchain model, a node and client are not always the same. In this model, blockchain client is always a program that can be installed in a user device. On the other hand, a blockchain node is a logical unit which acts as a single identity in the blockchain. However, a blockchain node may contain a cloud server and a Dew server, but blockchain client is always a Dew server. Dewblock developed on the top of the open source project Coin, available on the GitHub. It is a blockchain cryptocurrency system which concisely shows the basic principles in a cryptocurrency problem. Now, Dewblock app. It is a proof of concept implementation of a Dewblock client on mobile platform. It is a hybrid Android blockchain system application. It implements the Dewblock client architecture previously discussed using the principles of Dew computing. An existing implementation of Dewblock has already been written in Node.js, and I intended to re-implement as little code as possible when re-implementing the Android application. Therefore, it was required to find a way to develop an Android application that could support the existing code, which uses Node.js. There are lots of technologies out there that let you make mobile application using JavaScript, but most of the Node.js libraries are not supported by most of these technologies. React Native is such a technology which builds apps from JavaScript code, but it does not support most Node.js library functionalities in the apps. Therefore, it was required to find resources which allows Node.js application to be used in mobile development. I discovered a couple solutions, Node.js for mobile and Android.js. In the beginning, I tested both of them to see if they work. Because of the compatibility with React Native, the first choice for the development was Node.js for mobile. However, it does not fully support the file system, which is required for wallet-related functions such as recording the history of transactions, as well as some other security features. Therefore, I was unable to use it to develop Dewblock app. The second approach was with Android.js, which is designed to create hybrid mobile application using JavaScript. In addition, it's provided support for the necessary modules and features required to deploy Dewblock on the Android platform. Therefore, project continued with Android.js. Though some modifications to the existing code are necessary, using the described approach, it provided possible to transfer a majority of the existing Dewblock Dew server code. None of the core functionality was altered in this transfer. After the addition of a simple UI, the adapted code was tested using unaltered cloud server. In short, after exploring Node.js for mobile, its insufficient support for the file system required the choice of Android.js, which during testing was able to successfully incorporate the requirement features. Implementation continued, resulting in the Dewblock app, a proof of concept Dewblock on mobile. Dewblock app code is available on GitHub. It is open source. Further development needed to be done. A nice UI for the app with current implementation is needed for user to use the app. For example, user should be able to do transaction using this system, and the functionalities will transfer in a certain way that will be understandable to the user. In near future, we plan to remove Node.js library dependencies, allowing it to go from hybrid app to a full native app, possibly built entirely in React Native. This is expected to improve performance. By solving the size limitation problem in blockchain, Dewblock maintains the decentralized concept of blockchain while also making blockchain useful for end user on their mobile phone. This successfully demonstrates that Dewblock can be used on mobile phone. Further development of this sort of application will increase the acceptance of blockchain globally. Here are some references regarding my today's research talk, and I would like to thank everyone again for listening me.